In part 1, we left off looking at notation of an isotope name and a nuclear symbol. So down here in example 2, we have 3 different notations. One is an element square, which you'll find on the periodic table, and then the other 2 we discussed isotope name and nuclear symbol. So when we're looking at these element squares, we're going to take down element square, isotope, and nuclear symbol, break down each part, and then we're going to apply it to drawing some atoms and counting subatomic particles within a given atom. So let's start by labeling the arrows, and it says some terms may be used more than once. So our options are atomic number, which tells us protons, mass number, which tells us protons plus neutrons, and charge, which tells us protons minus electrons. The average atomic mass, the element symbol, and the element name. Those are our options. So in an element symbol, which are on the periodic table, you'll find at the very top of the square, this will always be the atomic number. And the atomic number tells you the number of protons. And that is the identity of the element. If we have 20 protons, now we have calcium. So as we change the number of protons, that will change the identity of the element. This K is our element symbol. Potassium, isn't that a funny name for K? But it is. K is the element symbol and potassium is its element name. And then our 39.098, this decimal number, is the average atomic mass. The reason that is an average is because we can have different masses of potassium. We could have a mass of 39, we could have a mass of 38. Those are called isotopes, where you have the same element but a different mass. And then on the periodic table, we just average all of those numbers together into a decimal. That is the mass, because we can't list out every single isotope or variation that exists, so we just average it and put it as one number. So this is what you will see on the periodic table for every element. And then the other 2 ways we can write our notation for atomic information is an isotope name. So we have potassium, again there's our element name, then we put a dash, and we put the mass afterward. Remember, the mass, this is our mass number, it is protons plus neutrons for our specific atom. Different than average atomic mass, which is the average of all of the isotopes that exist for an element. Mass number is for a specific atom. In this case, potassium 38. If we have the isotope name, we can find the atomic number, which tells us protons, on the periodic table. So the only drawback to the isotope name is it doesn't straight up tell us the atomic number. We'll have to kind of do a little game of hide and seek on the periodic table to find its number of protons. But everything is there to be able to figure out protons, neutrons, and electrons. And our third notation, nuclear symbol, like we said in part 1, the top right number will tell us the charge. So in this particular atom, it's telling us protons and electrons are the same amount. It's protons minus electrons, 0. 38 is our mass number. 19, bottom left, is the atomic number. Telling us protons, and our element symbol once again. These are just different ways that we can read the atom's information in a few different formats. Remember that the mass number is protons plus neutrons. So this number up here is protons and neutrons. This number down here is the atomic number. It's just protons. If I wanted to find the neutrons, I could subtract these 2 numbers from each other to find out how many neutrons. 39 minus 19 would give me the number of neutrons. The rest of the mass, that is not protons. In this case, it happens to be the same number as the protons, but it's not always that way. If I had a mass of, let's say, 39, then I would have 20 neutrons. If I had a mass of 40, I would have 21 neutrons. So my number of neutrons will vary, and that's what will change the mass. But my atomic number will stay the same if it's the same element, and that will only apply for the identity. If I change the protons, I have a new element, and it's no longer potassium. So let's take a moment to apply this on page, start on page 7. Okay, so we have 3 different applications of protons, electrons, and neutrons from our different notations. And we're going to write the isotope name and the nuclear symbol for each atom and identify all ions or isotopes that we see. So our notes at the top here say that protons change the identity, just like we talked about, and different atoms are called elements. Electrons change the charge. Atoms that have charge are called ions, and neutrons change the mass. Atoms that vary only by mass are called isotopes. So let's take a look at these atoms. You'll notice these are drawn in what's called a Bohr model. It has a nucleus, it has protons and neutrons located in that nucleus, and then it has electrons around it in what's called the electron cloud. But in a Bohr model, we show them in different energy levels, or sometimes we call them rings, or we call them orbits. Energy levels, all of those are used interchangeably to refer to the space where we see electrons. In the first energy level, you can hold up to 2 electrons, and in the second energy level, you can hold up to 8. That's important for filling the energy levels or orbits. 2 in the first level, 8 in the second level. So let's go ahead and write some notation. In my first atom, part A, I have 1 proton and 1 neutron. If we look at the periodic table, we find that 1 proton is hydrogen. So I'm going to write its name. And then the mass, we said, is protons plus neutrons. That's 1 plus 0, just 1. So there's my isotope name, hydrogen 1. Now let's write the same information using a nuclear symbol. Hydrogen has an element symbol of H. I have a mass of 1, and my atomic number, or protons, is 1. The charge on this one, we have 1 proton and no electrons. So if I have 1 minus 0, that is a positive 1 charge. For charge, we will show positive or negative by putting a plus sign if it's positive or a little minus sign if it's negative. There's our nuclear symbol for this atom. Part B, isotope name. If we look for 7 as the atomic number on the periodic table, we'll find this is nitrogen. Mass, add up protons and neutrons. That will always be located here in the nucleus. It's 14. Now we can translate that up to our nuclear symbol, 14 mass. 7 is the atomic number, and now all we have to do is figure out the charge. We have 1, 2, 3, 4, 5, 6, 7 electrons, counting what are on the rings, and 7 protons. 7 minus 7 is 0. This is a neutral atom because they are equal. Continue that process as you work through these. Anything that has a charge, you'll list under the analysis as an ion. So far, we have A is an ion because it has a plus 1. B is not an ion. Isotopes of nitrogen, that would be B because I have nitrogen and it has a particular mass. Since we are saying isotopes, that means there are going to be multiple versions of nitrogen. Maybe it has a mass of 15. Looks like this one is going to be nitrogen because it has 7 protons and its mass is going to be 15. So there's nitrogen 15. Okay, we'll go ahead and write that there. You'll just list out the the letters that go with each form of the isotope. The next application of isotope name and nuclear symbol is to count how many of each subatomic particle is in the atom in chart form like this. So notice it says choose 5. Choose 5 rows from the next 3 pages. So choose 5 here, choose 5 here, and choose 5 here. It gets progressively more difficult as you go through these. So start with page 8, and then once you do those 5 rows, move on. So we have isotope names. Let's do one of these together. So have a periodic table handy, and then we will start. All right, zirconium-96. If you do a little game of hide and seek on the periodic table, you'll find zirconium on number 40. Element square number 40 at the top. So that is telling us we have 40 protons. Now this one says identify the mass from the isotope name, determine the number of protons, electrons, and neutrons, then write its nuclear symbol, assume all atoms are neutral. If its charge is 0, that means protons minus electrons, they have to be the same number so that they subtract to equal 0. The mass on our isotope name is 96. Then what can we do to find neutrons? If our total mass is 96, we can subtract out the protons to be left with the neutrons. 96 minus 40, 56 neutrons. Then our nuclear symbol, zirconium, is Zr. It has a charge of 0, atomic number 40, mass 96. Ta-da! So choose 5 of those. On page 9 and 10, they're giving you different pieces of information. So let's try number 2 on page 9. Atomic number 56. Now look for 56 and it'll tell you what element it is. Barium. Looks like we have barium again, but looks like this is a different isotope. Mass is 136. So put a dash and write the mass. Remember, mass is protons plus neutrons. Continuing with our information here, we have 56 protons because of its atomic number. It says assume atoms are neutral unless otherwise noted. This one does not have anything else written next to it, so we'll consider it as neutral. And then lastly, neutrons, take your total mass, subtract out the protons, 136 minus 56, and you'll be left with neutrons, which is 80. Nuclear symbol, barium is Ba, atomic number at the bottom, mass at the top, charge on the top right. And lastly, do 5 on this one. Be sure to check the charge of each atom. So this is now adding in ions, where the charge will be different than 0 because our protons and electrons will be different. Let's just do number 1, iodine 127. So the iodine is number 53. That means it has 53 protons. Its mass is 127. Let's do the math. If there's 127 mass in that nucleus, subtract out the protons, and you're left with 74 neutrons. And lastly, the symbol, iodine, atomic number, mass. Protons minus electrons. We got 53 minus 54, which is -1. So this has a -1 charge on the ion or iodine. That's all of our practice for today. The other page is some history. So in part 1, we looked at the 2 different experiments, cathode ray and gold foil. Use this timeline to complete this concept check over the timeline and the different scientists and models.